Hello, Internet, and welcome to my series on the Hubless concept robot. And before I get started, I wanted to let you folks know that I have made a couple of videos on this robot when it was first assembled, and then I had all the electronics wired up and I gave it an initial bench test. If you haven't watched those videos, I recommend that you watch the first two videos of this series. Now, the next video I was supposed to post was an actual ground test. So, as I was testing this robot on the ground, I had an epic failure. And when I took it apart, I noticed that the drive shaft of this robot, I know it's pretty huge, but I'm just going to try to focus it pretty close. So, if you can look at the shaft broke and the motor came apart from the drivetrain. So I was supposed to post another video on the actual test. The robot moves pretty good, but it did suffer a setback. So I thought that I'll just make a video of how this robot actually works, because it's going to take me considerable time to take this apart and replace this shaft and then get the robot back into top working condition. So let's take this to the side and let's look at how the internals of the robot actually work. So this is my messy workstation. It's all about function, less about the form, and I'm trying to make the best of what I have right now. So I have many number of parts that I printed during the development of this robot. I had actually started this project because I wanted to sharpen my skills using Fusion 360. I had designed this robot in Tinkercad, but then the design became quickly unscalable. I couldn't manage, changing the designs and undoing and redoing a lot of things. So I decided to learn Fusion 360 and decided to take this project, a very tough one, a very challenging one, as my first Fusion 360 project with which I would learn the software. So during the course of my design, I printed a lot of parts, some of them as prototypes, some of them as sections, and some of them as absolute failures. And during the course of the development, I had to do some trial and error testing after taking many number of prints, and then come up with the final dimensions before I printed all of the parts. And I spent considerable amount of time printing these before the robot could be assembled. So these are all the prototype parts, and I'm going to use these parts and put them to some use and just give you an idea of how this whole thing works. So to begin with, I have this major part. This is the drivetrain. So from the shape of the robot, you can probably conclude that I have one of these on either side of the robot. So there are two on either side. Now this is the drive frame, and the drive frame has what's called as the drive cage. So I have a couple of rings. There's one at the bottom and there's one at the top. And if you look closely, these rings have an angle that actually matches these rollers. So two of these will make some sort of a race on which these bearings roll. So there's one on the other side and one on this side. And then I have what's called as a drive ring. So I have a couple of these. There's one on one side and one on the other. And what these drive rings do is hold these bearings in place. So I have four of them. I mean, I could have put more, but then that would be a lot of rotating mass. So I put in just four of them. But then I soon realized that these plastic bearings won't hold because they're too noisy, and plastic on metal just doesn't work very well. So I had to replace them with these. They are the ones that you usually find on 3D printers. They're pretty quiet, they're rubber, and of course, they have steel centers, so obviously they won't wear out just like these plastic bearings would. So I have four of these. that actually rotate around this drive cage. So, and you can imagine how four of these would look. I don't have any more of them. And then I have this ring that actually attaches itself to the drive frame. And this drive ring holds these four bearings together, and they revolve in this drive frame. So that's the larger side of it. Now, how is this driven? It's driven by a drive gear. And this drive gear is held on to the drive frame through this particular hole. And again, there is a bearing that is driven into it, and this gear goes on this bearing. And then there is a larger gear. I don't have a print, but we can see that later inside of this robot. So there's a larger gear that's attached to this ring, and when this smaller gear is driven by a motor, by a motorized system such as this hobby motor here, it rotates and in turn rotates the larger gear driving the wheel. So on one side you have a large ring gear, on the other side you have the wheel attached to it along with its tire. So if you now take a close look at this, there is the wheel on one side, and on the inside there is a large ring gear which is driven by a very small drive gear. So those four bearings inside that you see, I don't know whether I can hold that up clearly, but you can see these four bearings here that are held in the cage, rotating as the smaller gear drives the larger gear. Now this is a large wheel, and I have the tire that's been printed out of flexible filament. Now, the reason I wanted to do it this way was I did not want to have a hub and spoke configuration, meaning I didn't want to do something conventional. It's easy to do that. It's easy to print a wheel that has a central hub and spokes getting out of it, but I wanted to do something a little more different, a little more unconventional. And so I decided to go for this design because it also challenged my skills in Fusion 360. So overall, if you look at this, there is this drive frame, there is this drive ring, and there is this small gear here driven by this motor here, and there is this bearing that's pressed in, and also you can see that the motor here drives the drive gear. Now, how does it do that? Here I have a drive shaft adapter. Now, why do I have an adapter? Why would I not drive the gear directly? Well, the premise behind this idea is that this particular adapter has been made for this motor, this hobby motor. If I want to tomorrow upgrade to a larger motor such as this one, this is really beefy and its shaft configuration is different, then this won't do. So tomorrow, if I did want to drive my robot with this motor, which is pretty large, I have come to realize that I would all I have to do is take this out and replace it with another adapter. But for now, I think these two motors pretty much give a lot of torque, and I think that's pretty sufficient for a robot of this size. So coming back to how this gear is driven, so I have a drive shaft adapter, and it's screwed on to the drive gear, and the motor actually is press fitted into this adapter. Now that's where the problem lies, and this is where I think the failure, you know, just to say, I don't know. I think the press fit was the reason why the drive shaft adapter broke. That's because I have inserted this many number of times and taken it apart many number of times. I might have twisted the shaft many number of times, and as a result, it might have broken. So the solution for this problem was to print another adapter, but this time the adapter has been printed with 60% infill. which means the shaft is much more stronger and won't break. And second, I printed a sort of a drive bush that will go around, and it's press fitted, will go into the drive shaft adapter so that it will prevent the shaft from fraying or spreading out and breaking once sufficient torque is applied to these motors. So, with that, I think I should be able to prevent the motors from breaking the shaft. And when I put these into the robot, which I have done on one side, so you can see that I have actually put in the bush and then press the motor in. So hopefully this should be able to stop the robot from failing once too often because of a broken drive shaft. So hopefully in the next video, I'm going to go into more detail on the powertrain, meaning all the electronics and what drives this robot, and then we can probably get into testing this robot on the ground. Until then, I hope you enjoy watching all the videos in this series and finding this information helpful. I'll talk to you guys later. Bye.